Now we will talk about schematic diagram of boiling. It's divided to temperature regimes. high temperature 1200 Celsius. بعد كده عندنا low temperature 70 750 Celsius. Boiling reaction series. عندنا composition rock types. طيب عندنا two types of reactions, continuous reactions وعندنا discontinuous series. طيب عندنا أول حاجة calcium rich بلاجيكليز فلسبار calcium rich اللي هو عندنا continuous series of crystallization. بعد كده بينتقل إلى الصوديوم rich اللي هو برضو بلاجيكليز فلسبار. عندنا discontinuous series of crystallization. olivine started with olivine, pyroxene, amphibole, مايكا بيوتايت اللي هي المايكا السوداء. الاتنين دول بيتجمعوا لغاية بيوصلوا البوتاسيوم بوتاسيوم في السبار اللي هو الأرسوكليز. بعد كده مسكوفايت مايكا بيضاء and the last crystallization mineral quartz. وعندنا ال composition rock types ultramafic بريدوتايت كوماتايت ديت أنواع صخور فوق القاعدية. مافيك قاعدي زي الجبرو والبازلت. وعندنا الانترميديت اللي هي الصخور النارية المتوسطة زي الدايورايت والانديزايت. وبعد كده الفلسك اللي هي الصخور النارية الحامضية جرانيت ورايولايت. هيفسرها في المقطع التالي. نوسع شوية. طيب from this diagram shows two sides. The right side shows the continuous reaction related to calcic feldspar, calcium rich feldspar. لو ده كله بنتكلم على بلاجيكليز. Then gradually sodium replaced calcium forming calcium sodium rich feldspar plagioclase calcisodi. Then sodium rich feldspar plagioclase غني بالصوديوم. While the left side begins with olivine, which is the first mineral crystallized, followed by pyroxene, then amphibole, finally biotite black mica at the end. During the last stage of crystallization and after the most of magma solidified, crystallization of magma happens in the form of potassium feldspar اللي هو الأرسوكليز في الآخر, minerals, potassium feldspar minerals, then white mica, and finally quartz mineral is the last crystallized of magma minerals. بدل اللي احنا قلناه في الدياجراما. We can observe that crystallization of magma includes 6 group mineral systems arranged according to speed of cooling. 1. Olivine, the first crystallized mineral groups. 2. Pyroxene. 3. Amphibole. 4. Feldspar, plagioclase, and arsoclase. 5. Mica, biotite, and mescophyte. 6. Quartz, the last crystallized mineral. Principle of igneous rocks classification. Igneous rocks can be classified according to 1. Place of crystallization of rocks, which affects on the rate of cooling and texture. 2. Mineral composition of rocks, which depend on the chemical structure. First, classification according to place of crystallization and texture. A. Plutonic igneous rocks. The slow cooling, which occur to great depths in Earth away from its surface, allow large number of ions to accumulate at the crystallization center, consists of coarse texture and small number of large size crystals seen with the naked eye, which characterize these types of rocks such as granite, diorite, and gabbro, and bredotite, that is the plutonic igneous rocks. B. Intruded igneous rocks, when the magma flows to the surface but the surrounding condition does not allow it to flow to the surface. Now it's intruded between the surrounding rocks, then cool down and take different shapes and its texture. has larger crystals due to slow cooling in deep places, and small crystallized at the new places near to Earth surface, where the cooling is faster, forming intruded igneous rocks, which its texture is known as porphyritic texture, where large crystals are surrounded by small undergrounded crystals, which have almost the the same mineral composition as dolerite, microdiorite, and macrogranite. C. Volcanic igneous rocks extruded ديت بقى خارجية when volcanic lava extruded during volcanic eruptions into Earth's crust or near to it. The lava cools very fast, so it doesn't take enough chance for crystallization, so it's form a glassy texture, non-crystalline, like obsidian, fine texture, microcrystals of large numbers that can be seen by naked eyes like rhyolite, or frothy texture due to the presence of gaseous bubbles during crystallization, such as pumice. Now, volcanic igneous rocks, we have obsidian, glassy texture, we have rhyolite, fine texture, cannot be seen by naked eyes, and frothy texture had a gaseous bubbles like pumice. But observe this, but basalt, andesite, and comatite have glassy of fine texture، يعني متنوع ما بين الاتنين، يا زجاجي يا دقيق، نسيج زجاجي أو دقيق. Second, classification according to mineralogy, mineral compositions. A. Acidic igneous rocks, felsic, حامضي. It is the rocks that contain more than 66% silica and sodium and potassium feldspar اللي هو الأرسوكليز. Mica and quartz with ratio 25%. That is the ratio of quartz. And amphibole, it has a light pink color, crystallized at low temperature, less than 800 Celsius. The most famous example, granite, which has coarse textures, which is commonly used in constructions due to natural beauty, especially after polishing. Also microgranite, which has porphyry texture, intruded rocks, and rhyolite, which has fine texture, volcanic rock. Obsidian, which has glassy texture, also pumice, which has air bubbles, so it's lightweight. B. Intermediate igneous rocks. These rocks are intermediate in mineral and chemical composition, which has 55 to 66% silica, plagioclase feldspar, which is rich in calcium and sodium. Also contains amphibole, mica, and quartz, and a percent of potash feldspar, a little percent potash feldspar or feldspar potassium arsoclase. They crystallized at moderate temperature. Their color are moderated too, between light and dark. It's always intermediate. Their examples are diorite, which has coarse texture, microdiorite of porphyry texture, and the most famous of it is volcanic andesite related to Andes Mountains. C. Basic igneous rocks, mafic. These rocks are poor in silica contained, which ranges from 45% to 55%. They crystallized at temperature more than 1100 Celsius at the early stage of magma crystallization. These are rich in iron, magnesium, and calcium minerals, so its black colors, such as olivine, pyroxene, plagioclase, silica feldspar, and some amphibole. Their examples are plutonic gabbro, diorite of porphyry texture, and basalt, which is the most famous and used for road pavement. D. Ultra basic igneous rocks, ultramafic rocks that are poor in silica less than 45%. They are the first crystallized rock on cooling the magma. They have dark black colors, which are rich in olivine, pyroxene. Their examples are plutonic peridotite and volcanic comatite. Now we will talk about the diagram. This picture عندنا الفلسك جرانيت رايلايت ممكن نحط هنا مايكرو جرانيت وobsidian والبيومس. If you talk about chemical composition and mineral composition, olivine ultramafic is contained of most of it olivine, percentage of pyroxene, small percentage of feldspar rich in calcium, mafic feldspar rich in calcium, pyroxene small percentage of olivine, amphibole. هنا بقى عندنا intermediate. We have both of orthoclase feldspar, quartz, plagioclase feldspar, sodium rich, مايكا بيوتايت ومسكوفايت امفيبول. بعد كده عندنا الفلسك عندنا فيها بقى ارثكليز كوارتز بلاجيكليز ريتش ان صوديوم مسكوفايت بايتايت مايكا. عندنا طبعا اتجاهات الزيادات والنقصان لسيليكا كونتينز بتزيد في اتجاه الفلسك. صوديوم اند بوتاسيوم كونتنت بيزيد برضو في اتجاه الفلسك. ايرون مغنيسيوم اند كالسيوم كونتنت بيزيد في اتجاه المافيك والالترا مافيك. ودرجات الحرارة او درجة الانصهار بتزيد في الاتجاه ناحية الترا مافيك وبتقل درجة الانصهار ناحية الفلسك الحامضي. تمام. طيب figure represents the mineralogy of common igneous rocks, shows the silica percent, elements and temperature of crystallization. Equivalent igneous rocks, what is the meaning of that? They are an igneous rocks which have the same chemical and mineral structures, but they differ in a place of formation, texture, and grain size. Example, and grain size. In the same category. If we see the pictures there, we talk about the same category. That is the equivalent. Okay, but we will talk about granite. It's plutonic, coarse texture, and rhyolite fine texture. It's volcanic, but it's the same mineral composition and chemical composition. Same minerals that contained on granite and rhyolite. That is the meaning of the equivalent igneous rocks. But they are differ in place of formation, texture, and grain size. Example, granite. Granite plutonic, microgranite intruded, and rhyolite volcanic. That's all about equivalent igneous rocks. It's about the similarity of category on the chemical and mineral structure but they differ in a place of formation, texture, and grain size.